So guys, as you can see, our first variable is this first counter on the first row and third counter on the second row first column is incrementing by 1. This is one variable, and the other counter that is on the right, that is the second and the fourth counter, they are being incremented by 3. You can see that the loop repeats 100 times. After repeating 100 times, they both will go 0. This will go 100 because it is being incremented by 1, and this is incremented by 3. See, now we are using two variables, unlike the previous video whose link will be in the description. Take a look here. See, now they both go 0. So that's how the two variables are working. Let me show you the quick recap of the code. Now take a look here. In the code here, we took, instead of one variable, we added a second variable. Now to display that variable on the string, we will need this variable on the LCD, we will need a string. So we took another array of char, which is a string, that is increment 3. Now the first variable is converted to a string, and the second variable is also converted to a string. Then the first variable is displayed on the first row, first column, and the second variable is displayed on the from wherever the first integer ends, because we are using LCD out CP command. So wherever the cursor is lost, it will start writing from there. That is the second column. Now similarly, we now go move the cursor to the LCD second row. From first column, it starts writing the third counter, whichever the variable 1 is, and then again the second variable will be displayed on the wherever the first variable ends, because we are not giving any direction where the cursor should be. So where the cursor is lost, it will automatically write from there. Then the first variable is incremented by 1 and the second variable by 3, and the loop repeats 100 times, and after repeating 100 times, both the variables go 0. So this coding gives us this result. See, so simple as that. Hello guys, welcome back to learning microcontrollers. In this video, I will show you how you can run 4 counters using 2 variables on a 16x2 LM016 LCD using PIC16F877A microcontroller. This is the continuation of the series in which I am showing you how you can use various techniques to display more than one variable on a LM016 LCD. Sometimes it happens that you want to display the voltage, current, like you are making an energy meter, you want to display the voltage, current and power factor. Then there is a complaint that people say that the PIC16F877 is unable to display all 3 parameters. So I will show you how you can do that. So with 4 counters, it means that we are using 2 variables like current and voltage, and we are displaying 4 counters using 2 variables. So let's get started. So guys, as you can see, this is our PIC16F877A microcontroller, and the command I am going to use is the LCD out CP command in the micro C libraries, because we are using the method 2. In the method 1, we are only going to use the LCD out command, and in the LCD out CP command, we also use the cursor. So I will just snap the code and simulation file from my previous video, and then I will edit it and will show you how you can run now 4 counters using 2 variables. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. Now guys, this is our 16x2 LM016 LCD having 16 pins. Now to connect this LCD with a PIC, you need a potentiometer. A 10 kilo ohm potentiometer will be enough. It will be used to adjust the contrast of the LCD. And this potentiometer has 3 pins, 1, 2 and 3 like this. Now guys, let me show you the connections, how to do the connections. First of all, take a look at this LCD. If you hold it like this, then you have 16 pins, 1 to 16 from left to right if you hold it like this. Now guys, first of all, you connect the pin number 1 and 5 of the LCD, and then you connect it to the pin number 1 of the potentiometer, and then you send it to the common ground of the PIC like this. And then guys, pin number 3 of your LCD is the adjustable contrast pin. You will connect it with the adjustable pin of your potentiometer. In my case, it is the pin number 2 or the center pin of this potentiometer. Now guys, pin number 2 of your LCD is the VDD pin. Here you will give 5 volt to the LCD, maximum 5.5 volt. You connect it to the pin number 3 of the potentiometer, and then you send it to the VCC of the PIC. In this way, potentiometer gets the 5 volt and your LCD gets the 5 volt. Now guys, pin number 4 is the reset pin, RS pin. It can be connected to any available digital input output pin of the PIC, and if you select any other pin other than the one I am going to select, just change it in the programming, that's all. So you can use any available digital input output pin. I am going to use the pin number 15, that is pin number C0 of the PIC16F877A like this. Now guys, pin number 6 is the enable pin. I am going to use the pin number 16 of the PIC for this, that is pin number C1. And for the pin number 11 of the LCD, that is data pin 4, I am going to use the pin number C2 of the PIC. For data pin 5, D2, for data pin 6, that is pin number 13 of the LCD. I'm going to use the pin number 22 of the PIC, that is D3. And for the data pin 4 of the LCD, that is pin number D7, I'm going to use the pin number 23 of the PIC, that is pin number C4, like this. Now guys, pin number 15 and 16 of the LCD, they are for the LCD backlight. In case your LCD have a backlight, only then you will connect these two pins, else you will not connect these two pins at all. My LCD do have a backlight, so I'm going to connect the pin number 15 to the VCC and 16 to the ground, maximum 5.5 volt, because this will turn on the backlight of the LCD. Now guys, in this way our LCD is connected in the 4-bit configuration. Now these 4 pins, pin number 7, 8, 9 and 10, they are used if the LCD is being used in the 8-bit mode, while we are using the LCD in the 4-bit mode. So there is no need to connect these pins, just leave them floating. Now guys, in this way our connections are completed. Now let's go to the YouTube. I show you my previous video. So let's go to the YouTube. Okay, I go to my channel. I will share the link to my video in the description as well. So in the videos, here we have the older video, or we simply go to the playlist. So in the playlist, we have this LM016 based programming technique. This is the playlist, and this is the 3rd video of this playlist. Let's open this. Okay, the playlist has opened up, and in the playlist, as you can see, we have 2 videos. This is using one variable 16x2, and this is the second video. The first video is using LCD out command. Okay, let me pause this. Okay, this is the video LM016 16x2 LCD run 4 counters using one variable, and in this video we will be using 2 variables with a PIC16F877A. Method 1, that is the LCD out command. No, this is not the video. We will need the other, in which we are using the method 2. Okay, this one is the video. Okay, that is the second video. One variable with PIC16F877, method 2, that is the LCD out CP command. We will be using the cursor. So let's use this video. Now go to the description here, and in the description, this is a link to the Google Drive. Just go to this Google Drive, and from there you can download the files of this video, which we will modify for our new video. Here we go. This is the micro C4 PIC file. Just download it. Go here, click on download. Okay, wait, let it download. Okay, it is downloading. It's downloaded. Now download the Proteus file. Click on download. Okay, the Proteus file is being downloaded as well. Now go to the folder where you downloaded the micro C4 PIC file. Here you go. Copy it. Go to some suitable place where you will paste the file. I pasted in this new folder here, and then you simply extract the file here like this. And here is the folder, and in this you have all the files. Now go to your micro C. Let me show you how to open these files. Here is the micro C4 PIC version 7.6.0. I will also share the link to the video in which I have told you how you can download this software for free, full version. Now go to the new. Okay, first of all, open the file. Go to open. This window pops up. Go where you have just extracted your zip file in the new folder here. And here it automatically shows the C file. Just you will need the C file. Click on open. Okay, the C file opens up here. See, it has opened up. But the problem is, see, the debugger is not working. It will not debug the code. So you will copy this and make a new file. Go to the file, new. Here, click on next. Write the name of the project. I write LM016 PIC16F877A. Tutorial. Now it will be 4 counters and 2 variables by learning microcontroller. So that is the name of the project I wrote. You can write any name that you want. Okay, select the microcontroller PIC16F877, and the crystal I have is 20 megahertz. Okay, that is 20. Click on next and finish. Now guys, the new file is ready. First of all, before you do anything else, first of all, save your work, press Ctrl S and save it at a suitable place like this. Now guys, go to the other file we just opened, copy paste all of this, press Ctrl A, Ctrl C, here press Ctrl A and press Ctrl V. Now see, the debugger is working. And now go to the right, select the libraries, that are being used. The libraries we use for conversion library, then we have the LCD library. These two libraries. Now click on build and see if it builds successfully. Okay, that's perfect. Now what I do is that here you can see that we had only one variable above it. Okay, here you go, only one variable. Now we use another variable. I write increment 2. This is the second variable, and now since we cannot display this variable directly on the LCD, we will need a char for it. So we will convert this integer into a string to display it on the LCD. So I take another char, I call it increment 3, and it also has 10 digits. So simple as that. Now we have two variables, and now the counters were 4. Okay, here we go. First of all, what we used to do is that we run a do while loop, and it repeats for 100 times, and then after repeating it makes a initial variable go 0, and initially the variable is 0 as well. Now what happens is that first of all we simply convert this 0 to a string to display it on the LCD, and then we start writing from the first row. We are using the cursor, and from the first row, first column, it writes whatever the value is, and that is by default 0. Now the next thing is, what we do is that again we display this at the next place, because we have not defined any row, etc. So it will automatically start writing again where the cursor was last. So as soon as on the first row, as soon as on the first row, once this is written, from the place it ends, it will append the writing line. It will start writing the second counter, and then we move the cursor to the second row by giving the command, and then again it will write from the first column of the second row, and then from where it ends, it will automatically start writing from there the fourth counter, and then the counter is incremented by 1, like it was incremented by 1, and then it keeps on repeating until it becomes 100, and then the loop ends. Again it is made 0, and again it repeats all over again. So let me get the Proteus file. So first we run this code without modifying it. So let's go back to the link. Here we downloaded the Proteus file as well. Let me turn on the Proteus. Okay guys, there is our Proteus. Let's go to the file we just downloaded. So in the downloads, we just downloaded the second file. This is a Proteus file from the Google Drive. Go to the folder, again go back, paste it, extract it somewhere where it is easy to access. I extract it in the same folder here, and then I extract here like this. Now I go to the Proteus, and on the Proteus you go to your file, open project, and then you go to the folder where you have just extracted your file, and I had extracted it over here, Proteus file. Okay, here we go. So now the file is open. What I do is that I run the file I just had. So this is the file we just created, hex file, and first see does it work as it is or not. Okay, it is working fine. 4 counters using 2 variables. Now what I do is that I will change this variable. This is incrementing by 1, but I will make this to increment by 2, or I will make it, this will increment by 3. Okay, this will increment by 1. This first row first counter and second row first counter will be incremented by 1, while the first row second counter, second row second counter, this will be incremented by 3. That's how I modify this code. So we use 2 variables now. Now for the second variable, what I do is that I add I just copy paste this increment command. I add another increment command here like this, and the second increment counter is inc2. So go down, make it inc2 like this. Now this is our second counter. Oh sorry, this is the second counter here, and it is not incremented by 1, it will be incremented by 3, and it will keep on incrementing by 3. So that's all, and once the loop ends, it will be like 300, because it will repeat 100 times, so it will become 300. Once it becomes 300, then again it will be made 0 like this, and this will be the increment 2 counter, this one. Now this is our first counter, first row. Here we have our first row first counter, that is increment 1. Again, now whatever is in the increment 2, this integer, we cannot display this integer directly on the LCD. We will need to convert it to a string, and we also have a string over here. Now again copy this command, integer to string. We convert our second variable as well to a string, and this is increment 2, and the string I made for this is an increment 3. So whatever is increment 2 integer will be converted to a string and will be stored in the increment 3. Now first row, for starting from the first column, is our counter 1, and first row starting from where the first counter ends is our second variable. So it will be increment 3, this one. So we will be displaying the string on the LCD. And now again, from the second row, first column is the counter 1, that is the first variable, and from the second row where the second counter, that is our fourth counter, starts, that will be our fourth counter, and that will be from the variable 2, like this. Now I build this code. Now we are using two variables. See, no errors. Our first variable is the increment, which is incremented by 1. Our second variable is the increment 2, which will be incremented by 3. Our first counter on the first row will be the variable 1, and the second counter on the first row will be the variable 2. Similarly, on the second row, the first counter is variable 1, and the second counter will be variable 2. So let's build this again and go to the Proteus and see does this code works or not. So now I run the code. See, it is working like a charm. This counter, see, increments by 1, while the second variable is incrementing by 3. See, 27, 30, 33, 36. Now suppose this is our voltage and this is our current. That's how you are going to make it work using the LCD out CP command. So guys, this is simple as that. If you guys have any questions or comment, you can either comment them or you can ask me in the comment. I will be greatly acknowledged by your recommendations or any objection that you have. So guys, this will be a great thing to hear that you guys learned something from this video. Thank you very much for your time, and we'll see you in the next video. And goodbye and have a nice day.